This video will cover the topic graphing a function of the form f of x equals ax raised to the second power plus c.
What would a problem of this type look like?
Good question. An example of this type of problem looks like this. Graph the function h of x equals 2x raised to the second power minus 5. Plot the points on the graph with x values -2, -1, 0, 1, and 2.
This problem has a lot of numbers to deal with.
That is true. So let's start by organizing our information. Our function h of x equals 2x raised to the second power minus 5 is of the form f of x equals ax raised to the second power plus c. The a value of our function is the numerical coefficient in front of x raised to the second power, and the c value is the y-intercept. In this situation, the value of a is 2 and the value of c is -5. Now that we have that organized, let's create a table for our function. First, we fill in the x values we will be using to plot this function.
Oh, okay. So for this problem, we will be using the points -2, -1, 0, 1, and 2, right?
Exactly. So let's go ahead and put them in the table. So now we can find the corresponding values for f of x.
Okay, so how do we solve for these values?
Well, first, it's important to remember that f of x is just a different way to refer to the y values in a function. So in order to solve for f of x, we substitute the x value into the function wherever x is present, and then solve the rest of the problem. Let's start with x equals -2. Our first step is to substitute the x value, in parentheses, into the function wherever x appears. Because we are starting with x equals -2, our function will look like this. Now we will begin to solve the problem. First, we calculate -2 raised to the second power, which is 4. We then multiply 4 by 2, which is the a value of our function. Now that we have found that the value of ax raised to the second power for our function is 8, we can add it to our c value. In this function, the value for c is -5. 8 added to -5 is 3. We have found that the value of h of x at -2 is 3. So the first point on our graph will be -2, 3. Would you like to try the next one?
Sure. This time, our value of x is -1. The first step is to substitute the value of x into our equation wherever x appears. Now that we have the value of x in the equation, we can solve the problem. First, we raise the x value to the power of 2, which gives us 1. We then multiply 1 by 2, which is the a value of our function, to give us 2. Now, we can add together 2 and our c value, which is -5, to give us a value of -3. This means that when x equals -1, h of x equals -3. So the next point on our graph will be -1, -3.
That's right. It looks like you've got it. Once you solve h of x for the next 3 values, you'll have a total of 5 points of the function that you can graph. The first point we have to graph is -2, 3. We graph this point by first finding where it lies on the x-axis. We start at the coordinate 0, 0, and since the x value for the coordinate we're graphing is -2, we will move 2 units to the left on the horizontal line. Now, since our y value of our coordinate is 3, we will move up 3 units on the vertical line. You will do the same for the next 4 points, and your graph will look like this. Now we will finish off by connecting our points, and we have successfully graphed our function.
Okay, so just to make sure I'm getting this straight, to graph a function of the form f of x equals ax squared plus c, I begin by figuring out what the values for a and c are of my function. I then create a table to organize the x values, the values for f of x, and the coordinates of the points on the graph. For each x value given, I can solve for f of x by substituting the x value in the equation wherever x is present. For functions of this form, I begin by raising x to the power of 2 and then multiplying that number by a. We then add this value to the c value of the function. After doing that to all the x values, I plot the points on the graph and then connect the points.
That sounded perfect.